Up to this point, we've discussed a few functions, including rational functions and polynomial functions, as well as exponential and logarithmic functions. But there's another group of functions that we'd like to revisit, and these functions, you were introduced to these functions in geometry. So these functions are sine, cosine, and tangent. And as you know, sine, cosine, and tangent are basically ratios of lengths of sides of a right triangle. So what do we mean? Well, suppose that we have a side here, an angle here that we're referring to. The opposite side would be basically directly opposite. So that would be right here. So this is our opposite side. Adjacent, another way of saying adjacent is close. So if this is our angle, where is our close side? Well, this is our close side. So we call this side adjacent. So this is our adjacent side. Our hypotenuse is the longest side of our right triangle. So that would be the side that is directly opposite the right angle. So if we start at the right angle and go directly opposite, we'll end up at the hypotenuse. So when we take the lengths of these sides, we're going to get our trig values. But what if we chose a different angle? So suppose that we had chosen this angle here up at the top. Where would our opposite side be? Well, if we go directly opposite, it would be straight down. So this is our opposite side. Where would our adjacent side be? Well, it would be right next to the angle. So this would be our adjacent side. So here's our adjacent side. Let's see if we can apply these trig ratios to find the sine, cosine, or tangent of given angles. If we had a 30, 60, 90 degree triangle, so 30 is one side, 60 is another, and 90 is another, we remember that the sides would have to be 1, 2, and square root of 3. So the side opposite the 60 would be square root of 3, the side opposite the 30 would be 1, and the side opposite the 90 would be 2. Remember that sine, as a trig ratio, is basically opposite over hypotenuse. So if we wanted to do sine of 30 degrees, well, here's 30 degrees. Directly opposite that is 1, and the hypotenuse would be 2. So for 30 degrees, we'd have 1 over 2 as its sine. So let's suppose that we wanted to choose the sine of 60 degrees. Let's rewrite the numbers. So opposite the 30 is 1, opposite the 60 was radical 3, and opposite the 90 was 2. So if we wanted sine of 60 degrees, remember that sine is opposite over hypotenuse. So the opposite side of 60 is radical 3, and the hypotenuse is 2. So it's going to be radical 3 over 2 for the sine. If we have this special right triangle here from geometry, hopefully remember that if we have a 45, 45, 90 triangle referring to the degrees of the angles, that the sides would have to be 1, 1, and square root of 2. So let's fill those in. So we have 1, 1, and square root of 2 for our sides. So if we wanted to find the sine of 45 degrees, remember sine is opposite over hypotenuse. So if we're at 45 degrees, 1 is exactly opposite, and the hypotenuse is radical 2, so it's 1 over radical 2. We should note, though, that this is not how it's normally written. Normally what happens is we don't want a square root in the denominator, so we do what's called rationalizing. So if we have 1 over square root of 2, we're going to multiply by square root of 2 over square root of 2. basically what we already have. So 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is square root of 4. And we already know that's basically just 2. So what we know is that the sine of 45 degrees is 1 over square root of 2, like we said, but it can also be written as square root of 2 over 2. For cosine, we should remember that cosine is the adjacent or close side over the hypotenuse. So if we wanted 30 degrees, remember this is the adjacent side and this is our hypotenuse. So we need these two if we're doing cosine of 30. If we're doing cosine of 60, 60 is here, so our adjacent side is here and our hypotenuse is here. Remember, adjacent over hypotenuse gives us cosine. So let's fill this in. So let's say that we had, this should be square root of 3, this should be 1, and this should be 2. So if we were to find, let's say, the cosine of 30 degrees, cosine of 30 degrees, we can go opposite 30, excuse me, we're going to go adjacent, so let's fix that. So 1, 2, square root of 3. Remember, cosine is adjacent over hypotenuse, so cosine of 30 is going to be, this is our adjacent side right here, so square root of 3 over 2, so that's what our cosine would be of 30 degrees. So let's say we wanted the cosine of 60 degrees. So here's our angle 60. This is the adjacent side for 60. So that would be 1 for our adjacent side. And our hypotenuse is 2. So cosine of 60 is 1/2. We can similarly find the cosine of 45 degrees. So again, 1, 1, square root of 2. So for 45 degrees, the cosine is adjacent over hypotenuse. So that would be 1 over square root of 2. And do you remember how we rationalize this? Remember that we had to multiply by whatever square root we already had. So if we multiply by square root of 2 over square root of 2, then our final answer is just going to be square root of 2 over 2. So cosine of 45 can also be written as square root of 2 over 2. If we want to find the tangent, first of all, we remember that the tangent is opposite over adjacent. So let's go ahead and fill in the sides. So opposite 60 is radical 3, opposite 30 will be 1, and the hypotenuse here is 2. So let's say that we had to find out what the tangent of 30 was. So here's 30. Directly opposite 30 is 1, and adjacent to 30 is radical 3. So we would have 1 over radical 3. Remember that we need to rationalize. We don't want square roots in the denominator. So we're going to say 1 over radical 3. We're going to multiply by radical 3 over radical 3, and that's going to give us radical 3 over 3. Remember, square root of 3 times square root of 3 is equivalent to square root of 9, and square root of 9 is just 3. So tangent of 30 is radical 3 over 3. All right, if we needed to find the tangent, let's say of a different angle, let's say of 60, so tangent of 60, now our opposite of 60 is radical 3. So we have radical 3 in the numerator this time. And our adjacent to 60, or the close number to 60, is 1. So it's radical 3 over 1. If we divided this, then we're just going to get radical 3. We would apply a similar process even if we have a different angle. So tangent is going to be opposite over adjacent. So for our 45, 45, 90, remember that opposite the 45 is going to be 1, and opposite the 90 is radical 2. So if we do tangent of 45, then it's going to be the opposite of 45. So here's our 45. Opposite is 1, and adjacent is 1. And if we divide them, we get 1. So tangent of 45 degrees is 1. So just to recap, if we have a given angle, whatever the angle is, the opposite is directly opposite. We could just draw a line and go straight across and we can reach it. So this would be the opposite of that angle. The adjacent would be what's close to it, and the hypotenuse is always the long side. And if we were to change the angle, so let's say that this is the angle here, then now we go opposite. So this is now our opposite for that angle. And this side here would be our adjacent. But our hypotenuse would always be that longest side. If you want a short way to remember, you can just say that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So, ka, toa.